Here's the hose. It looks like this. Two ends with metal connectors. That is one end. The other one is inside for now. That's a larger one. That's the male, and the large one is the female. Airmaster spiral hose with two quick joints. The exterior diameter is 8 and the interior diameter is 5 mm. That one, 90 mm is this diameter. The length when it's extended is 10 meters. Right now is 1.5 palms. And quick joints. Levegő spiráltömlő gyors csatlakozóval, that's in Hungarian. Furtun spiralat cu racorduri rapide, that's in Romanian. It's a plastic thing, let's open it. So it looks like that. It's pretty large. That's the female connector. It has a rubber seal inside. This portion is moving. Oops, that one is broken. Just in case you abuse it, it breaks. There's a longitudinal crack on it. And this can be connected there. So you pull down this one. Notice there's a space here, so when I push this in, this goes to the right, like so. Pull it and it comes off. Of course not this to that one, because it's a closed loop in that case. Here's an inflating gun with a pressure gauge. It looks like this. It has a manual. It says inflating gun, so I guess there are two versions from this. I have this one, which is black. The other one has maybe a cut inside here. This does not have it. Maximum pressure is 10 bar, 145 psi, 100 liters per minute. You can use it for bikes or for cars. Put it on the valve. It has this part where you have to push that thing down and it opens that part. That one in the inside, which is moving, that grabs the valve. Mount it on the valve, and when you push the trigger, the air will flow from down there. This unlocks it and exits here, and meanwhile you can see the pressure. When you push the trigger, then you see the pressure of the source, your compressed air tank, for example. When you release the trigger, then you see the pressure on the left side, let's say inside your car tire. So when it's pushed, you see the pressure on the right side from the trigger to that one. When you release it, you see the pressure on the left side from the car tire to this pressure gauge. It has a quick release mechanism here. It has an opening here. It's empty inside. Stanley. That's metal. Pressure gauge is in bar and psi. It has a rubber cover. You can remove that one, it's soft rubber. This is rubber also, flexible. Push it down and then insert it. This side has thread. You can insert multiple elements here into this one. As you can see it there, A, B and C. Here's the hose. It has this connector that would go here to this one, like so. So to attach it, you just push it, and to remove it, you pull this portion to the left. 200 liters per minute, 10 bar pressure, inflating gun, 170, 533 XSTN. And here's the car tire. There's the valve. Remove that rubber cover. You can attach this one, and when you attach it, the air from the tire will go into this hose. And luckily I don't press that down, because otherwise it will escape. So let's just try it. So open it up, push it in and release it. Something like that. It doesn't like movement, and it shows the pressure, 2.6 bars inside the tire. Now if I press this one, the air will exit here, just a tiny amount. As you can hear, it exits. Now if I remove this one, the air will exit from this hose. Do it quickly, and that's it. Put the cap back. So just by mounting this side onto the tire, you can measure the pressure of the tire. Notice the needle went back to 0. So when there is pressure here, it goes up. When there is no pressure, it automatically comes down. If I blow air here, I must push that one down and then air escapes. So let's just try it. No pressure is measured there, because just with my mouth I cannot create 1 bar, not even half of it. The same thing with the other end. If I put this one in my mouth, whenever I push that down, the air exits there. So air has to be blown here in, that has to be blocked, this has to be pulled, and then when you push this down, air exits here. So this goes into my mouth. So even if the trigger is not pulled, air from the left side can exit here when it's pushed. Here's a pressure gauge. It has a hose, okay, and this blue plastic hose. This spiral has a crack in it. Maybe it's visible. So push this one to the right and it will come off. And to remove this one, simply rotate this spring. It's a soft metal. Rotate it a little bit to the right, and thus the diameter will get a little bit larger and you can pull it to the right. So hold this one, rotate this to the right, and notice it's coming off. That's it, and there's the large gap cut. Now let's see if I can cut that down using a simple knife. Let's see, somewhere there. Yes, it's cutting it pretty easily. Now let's see, can I put this here or it will break once again? Or I should heat it up a little bit. It's pretty hard. Let's try to blow some warm air onto it. So here's a hot air gun. It's just 300 watts. Without burning myself. It's getting hot. Looks like it's even melting. It's pretty soft. And it's done. Now to put it back, the same thing. To make the diameter a little bit larger, rotate it to the right, clockwise. And that's it. Job done. Now I can put that back there. Now I should blow some air here with my mouth. And it does not escape anywhere. Since this has, I'm not sure, 10 meters, I can blow the air into it and I can feel the compression. It's like a spring. I can feel it compressing and then releasing. That's pressure from my mouth. That needle will not move. So this much was cut off from the 10-meter long tube, and this opening is not creating any problems anymore. And this is the other end. It also has a spring here. If you want to remove this one, the same thing, rotate it to the right and it comes off. Removing this is more difficult. Oh, now that's barely moving or not moving at all. The metal is hot. It might even break. It's getting thinner. Or maybe it's a better idea to cut it off. So you can barely remove it. So let's just cut it off. So the removal is not too easy. The plastic copies the shape of that metal and it's not elastic, it's not letting me remove it. By the way, this end, this metal part, does not let air escape. So if I start the compressor a little bit, just plug it in, air is not escaping here. Compressor started, compressor is unplugged, nothing escaped there. Plus I cannot even push in this one because it's blocking it. Notice there is some pressure. Now it entered. Now if I press this, the air from the hose escaped. So once again I plug in the compressor, fridge compressor. Just a few seconds. Nothing is measured here because that is measuring the pressure from this end. And now it's spiked up a little bit. The blue hose is moving. It's expanding due to the pressure. Let's see if I don't move these. Will the blue hose move as I release the air? Yes, it's moving. Once again, I'm plugging in the compressor. It's barely doing anything. And I'm releasing the air. And the hose is moving. So the air is accumulating inside this tube. Between the fridge's output, that's the output, that's a I think 10-meter long hose, and this is blocking it only if this one is missing. If that is coupled, then this portion is blocking it. It's blocking the air. So I'm going to plug it in again, make some pressure till here, and then I'm going to try to decouple that one. Pressure is disconnected. Let's see. The air should be automatically blocked by this one, so it should not escape too much to the right. It's even pushing it away. But there should be air inside this one. Compressed air. Just by pulling it down, it's not doing anything. Yes, there is some pressure. Yes, it remains some pressure in it. By the way, I cannot block this end with my finger because there are openings there at the side, so blocking it this way will not help. So I cannot measure the pressure inside that hose unless I remove this one. Now let's try it this way. Plug it in, disconnect it, put the finger there, and let's see the pressure. Oops, 2 bars and my finger has been pushed away. So I can hold 2 bars with my finger. but it's pushing it away quite well. There is quite some pressure, so you can stop 2 bars of pressure with your finger at 1 centimeter diameter. Let's see once again. Now let's try another finger. Oops, it's pushing my finger up. The pressure went to 3 bars, I think. 2 bars. Now let's see, I'm pushing it gently. Will the air escape? So I'm not pushing it with large force. Yes, it will escape. Okay, and this is not doing anything right now until I release the air from that portion into this portion. Yes, 2 bars, and now, yes, now from this portion, that button releases the air. Pressure inside this one, this is releasing it. So this is measuring the pressure between this portion where this is blocking it from there to the top. Let's say a car tire, bike tire, whatever. And this has a rubber seal, and that is protecting the air from escaping. And that is rotating. If I power on the compressor, the air is being compressed into this tube. There is no storage tank, nor a switch, a presostat or something like that, which would stop the power in case of a high pressure. So this is very unsafe. Do not leave it connected to power because it will explode. No pressure sensing device is connected, which would stop the power from entering into the compressor. In this portion, the blue plastic is just pushed onto this copper pipe. I had to blow the end of the blue plastic with a heat gun to make it softer and expand a little bit. Blow the end of the plastic, not from a little bit to the right, because here it will be soft and there it will remain hard because the copper is very good heat conductor and it cools it down. So it becomes hot here, and when you are pushing and pulling it, it will break there. It will be very soft. So always blow with hot air the end and then push it to the left. And the spring is holding it quite well. You don't need a metal clamp. There is oil in it, and that oil might escape and it will go down, which is not quite a good idea. Plus I cannot really rotate this up. I mean, I can, but I will force it just to force the oil to go back a little bit. But of course the higher flow of the air can push it all the way to the front. The fridge compressor is pretty powerful and very silent. I have to mount a switch of some kind somewhere, not to use all the time this one. In this end, that's the input. Air enters here. The other one is blocked. I'm not sure what's that. So air enters here and air exits here. Enters and exits. This is bent down, not to draw something in very easily. Hopefully some larger particles could fall down, just in case they are absorbed. Plus there is this thinner tube, which is inserted that much, that is totally useless for the compressor, that is used for refrigeration. A small portion of that pipe, it's very tiny, a small portion is being cooled down